everyone, my name is Muhammad Ali Fidaus bin Rozaini. My matrix number is A6679. Oh, salah.
Good day everyone, my name is Hazid Safir Rahman and my matrix number is A5596.
Hi, my name is K2T3, daughter of Shanmugamani, and my matrix number is A5491.
My name is Arif Iskandar bin Zawani and my matrix number is A5920.
My name is Muhammad Safwan Akil bin Muhammad Zulaini and my matrix number is A5535.
Today, our group will be presenting about our mathematics assignments on the topic of continuous data for ungrouped data. Let's get right into it. Continuous data refers to numerical data that can take any value within a given range, including decimal or fractional values. Unlike discrete data, continuous data are typically measured rather than counted. Examples include height, temperature, weight, and time. Next, what is ungrouped data? Ungrouped data is known as raw data that has not been placed in any group or category after collection. It is categorized in number or characteristic, which has not been put in any of the categories. Is ungrouped. For our real-life application, we conducted a survey to analyze the daily phone screen time of students for over 7 days. Using the dataset, we will compute and interpret the mean, the mode, median, quartile, the interquartile, the variance, and lastly, the standard deviation. This presentation were made in order to demonstrate how continuous ungrouped data can be analyzed using descriptive statistics and applied meaningfully to a real-life situation.
To give you an example, phone screen time can be very different between each person. It can be 4 hours or 4.2 hours and maybe 4.37 hours. So basically this confirms that all of the data are continuous because decimals are allowed. In contrast, group data are organized into class intervals such as 0 to 2 hours or 3 to 5 hours. However, our study uses ungrouped data, meaning each individual value is recorded exactly as reported by respondents. Using ungrouped data provides several advantages. First, it preserves full accuracy because no information is lost through grouping. Second, it allows exact computation of statistical measures. Third, it enables more precise interpretation of variability within the dataset. Therefore, our dataset satisfies both conditions required for this assignment. It is continuous and ungrouped.
To collect our data, we designed a Google Form survey titled Average Daily Phone Screen Time Among Students. Participation was voluntary and anonymous. We sent the Google Form surveys, aka links, in WhatsApp groups such as our K2T3 group. We sent it there and many people voluntarily answered the Google Form survey, which was really great for us. Respondents were asked to check their phone's built-in screen time tracker and report their average daily screen time over the past 7 days, measured in hours. Here are the raw data values collected. These values will now be analyzed using measures of central tendency and measures of dispersion.
Hi everyone, so now I'm going to walk you through my calculations step by step and explain what each value actually tells us about the data. First, I have organized all the screen time values into a table. With the screen time, I have labeled as X, the frequency, which is the amount of people that have responded, and finally the cumulative frequency, which keeps a running total as we go down the list. Now, altogether, there are 24 people that have responded to our survey. Now, let's start with the mode. The mode is basically just the value that appears most often in our data. So here we look at the frequency column and we see that the most frequent value here is 5 hours. So that means the most common screen time among the group is 5 hours. Next is the range. The range is what tells us how spread out the data is from the smallest to the largest. To find it, I just do 12.3 minus 1, which gives us the value of 11.3 hours. Well, this shows that there's a big difference between the lowest and the highest screen time. Now let's talk about the mean. The mean is basically just the average, and to find it, I have multiplied each screen time value. So 1 times 2, 2.1 times 1, 2.3 times 1, 4.6 times 2, and so on. Then I have added everything together, and that gives us a total of 146.27. Then I divided it by 24. That gives us an approximately 6.12 hours. So on average, students had spent over 6 hours on their phones. After that, the median. So the median is the middle value when all data is arranged in an ascending order. So since there are 24 values, I simply just divide it by 2. So that means the value falls between 12th and 13th order. Well, from the table, we see that the data is right here. It gives us 5.5 hours. So the mean is really useful as it shows the center of the data without being affected by very high or very low values. Then I found the quartiles. So the quartiles divide the data by 4 parts, basically. So the first quartile, quartile 1, is the value at 1/4 of the data. So when we look at the data, it is right here. That gives us the value of 4.8 hours. And for quartile 3, it is at 3/4 of the data, which gives us the 18 value right here from the table. That gives us 7.7 hours. To find the interquartile range, we simply just subtract Q1 from Q3, which gives us 2.9 hours. So this tells us how spread out the middle half of the data is. It also helps us to understand the typical variation without being affected by such extreme values. So moving on to our variance. So variance is what measures how far the data value spread out from the mean. So I've used the formula that involves subtracting the mean from each value, squaring it, multiplying it by the frequency, and then divide it by the total of frequency, which is the amount of people. By doing all of this, I have calculated the top half of the equation to be 205.1504. So when we divide it by 24, that gives us the value of 8.5479. To find the standard deviation, we simply just square root the variance that we get from up here. And that gives us approximately 2.9237, meaning most people's screen time tends to vary about 3 hours from the average. So overall, these statistics help describe the data in different ways. The mean and median show the center, the range and interquartile range show the spread out, and the variance and the standard deviation tells us how consistent or varied the screen times are. So the lower the standard deviations are, the more consistent the data is. And that's my full explanation of the calculations.
So in conclusion, our study demonstrates how continuous ungrouped data can be analyzed effectively using descriptive statistics.
Understanding screen time patterns can support awareness of time management, productivity habits, and digital lifestyle balance. Institutions may use similar statistical methods to study students' behavior and design awareness campaigns.
Through accurate calculations and interpretation of mean, median, quartile, and variance and standard deviation, we have shown how mathematical concepts apply directly to real-life situations.
Thank you for listening to our presentation.
Bye.
Bye-bye.